Well, today is the day we're going to be getting our very own Kaeser air compressor and get it installed. So back whenever we installed this system right here, I had mentioned that my air tower was not completed yet. It's still in process, for being manufactured. So what Air Power Services did is that this is a unit that they own, that they use as a loaner or put it in place if they have to work on a customer's air compressor and it's down. As a courtesy, they will install some of their own air compressors in there temporarily until they get their customer's air compressor back online. And so that's what they've done for me, is that they installed this air center, which is basically the same unit that I'm going to be getting. And so I've been using it this summer. So my unit was delivered whenever we were on our IMTS trip, and they called me and said, we got your air compressor, and whenever you get back, let's get it installed. So that's today. They should be here very soon with the air tower, and they're going to get this guy swapped out. So it should be a very simple disconnect of the air line, some power, and my small pallet jack will actually fit underneath here. They'll be able to easily pick this up and get it out of here, and we'll get the new air tower in its place. Our new compressor has arrived. Let's take a look at it. There's our new air tower, the 5C. This is a 5 horsepower air tower. So you can see it's physically about the same size as the air center, which we've been running, just a little different configuration. This one's got a little bit bigger tank there, just mounted vertically instead of horizontally like the air center is. So that's it. Excited to get it all hooked up. I've got borrowed my buddy Joe's forklift so we can use it to get it down off the truck. The guys are in there now. They're going to start unhooking the other unit so we can get it swapped out. So we'll get all this hooked up, and I'll bring you guys back and show you a video of it running and kind of compare the noise level to the air center versus the air tower there. So our new air tower is successfully installed. Everything is ready to go here. So Air Power Services, they showed up yesterday with the air compressor and got everything hooked up. Took a few hours to kind of get everything situated and run through their spec sheets and everything. They went over it with me, and we are ready to go. We have a brand new air compressor ready to run the shop here. So in case you guys missed it before, the other unit that was here, which was the air center, that was a loaner unit from Air Power Services that they let me use until my unit was manufactured and delivered and ready to go. All right, so let's fire this guy up. It is, let me just go ahead and kick it on here, and we'll listen to this guy run, okay? There it is. I would say that the noise level of the air tower is slightly higher than the air center that we had here, but not a big difference at all. You can still stand here. You can stand here by the machines with it running. It's not intrusive. It's not loud and noisy like a piston compressor. And one of the reasons why I wanted a compressor like this in the shop is to reduce the noise level. All right, we see it building up pressure there. This is a really nice unit, just like the air center had. You can get on here and check all of your maintenance schedules for everything that's got to be maintenance. You can see Air Power put their next service, which is going to be a year from now, and they'll come and check it, or 500 hours. And you can actually go into the menu here, and all of the maintenance things that need to be checked, like the belt and the oil, it's listed in there of how many hours is left. I believe we can go, let's check this out. I think we can go to, it was maintenance. Okay, so it's telling us how many hours are left for the oil filter, which is 3,000 hours. Oil separator, 6,000 hours. Oil change, 3,000 hours. Air filter. So you can go in there and check to see what your maintenance is looking like and when it's going to be needed for this unit right here. Really nice, really nice. It's physically about the same size as the air center that was here. This one's just slightly shorter. So one of the things that that Brad at Air Power explained to me, some of the differences between the air tower and the air center is the way that they manufacture the air tower is they try to reduce the cost a little bit, approximately 20%, for a little bit of a cost savings for the customer. For example, the dryer has to plug in to the 110 here, and that's what this guy is. So you got to have a 110 source for the dryer there. And what that does is it kind of eliminates, I think it eliminates another transformer in there, so that you have two separate lines hooking in. So you have your main power and you have your 110, but eliminating the transformer kind of reduces some of the cost. Another one of the things is this is a plastic enclosure around the machine. So the air center, you remember, it had a metal enclosure, and having the plastic enclosure also reduces the cost a little bit. So it really just kind of depends on what your budget is and what it is that you're wanting out of the unit there. This is perfectly fine for me. I think it's a beautiful air compressor. It's well engineered and designed, and it's going to fit my needs perfectly for what we're going to be using it for here in the shop. There it is unloading, because we've reached our, they've got it set at 145. And what it'll do, just like the air center, it's just gonna unload. It's gonna run for a little bit of amount of time, I don't know, probably about a minute or so, and then the unit will shut off. But these are designed to run at 100% duty cycle, so if you need to run this non-stop, if you're constantly supplying air to your equipment or machines or your shop, these are designed to run non-stop if that's what you need them to do. Thought I'd give you guys a little closer look at the workings of the compressor there. So this is the plastic shroud, the cover. It's a very simple design. It basically just lifts right off there. So there's no tools required. It fits on there nice, just like it's supposed to. So of course you got your display, the computer and everything. Your electronics are all right here behind this panel. And then back here you've got of course you got your storage tank. There's the motor, and then there's that's the screw right there. This is a lot smaller than I actually expected to see. I thought they were going to be a lot bigger than that, but that's the screw right there, or the two screws that pump the air. You got your filter there. Let's see, I believe this is the condenser. You have your dryer down there. This is the oil separator, and of course you got your filters. And I remember, let's see, so this is your oil drain line right there that actually just plugs into this guy that they'll use whenever they come to drain the oil out of it. That's really it. Very clean, simple design. Take a look at this side right here. That's about it. I don't know what else to show you guys on this, but it built up to 145 and then released, and I don't know, it ran less than a minute, and then everything shut down. So that is it. That's going to kind of complete our new Kaeser install for the compressor. And again, really excited to finally have this in the shop and hooked up. And I'm going to get the shroud back on there and jump onto some machine work. We've got some other projects that's just come in from the welding shop I got to get started on, so we're going to jump on that next. I've got this piece of 1/2-inch plate that I'm wanting to square up, and I'm using the Miltronics for this, but I'm using it kind of manually. I'm using the pendant here and controlling it with this guy. I don't know if this is like proper operating sequences. And some of you CNC guys, I don't know if you do this or not. I just wanted to square it up. I didn't want to have to do a bunch of extra work. I just want to square it up. It's just a little fixture plate. Two sides were flame cut, and then the other two sides were bandsaw cut. Nothing was square. Using my MMM Piranha jaws to bite into it, hold it real good. But I just wanted to show you what I was doing here. So I've touched off, and I think we got 30 thousandths there. I'm using the current coordinates here just to see what my offset is. All right, let's see, we got it in Y. I'm going to I'm just using some air, try not to make a mess. That's all I'm doing. Like I said, I don't know if this is kind of a stupid idea, that some of you other guys do this or what. So we're gonna go to X, and then we're gonna go another 50 thousandths. Got about a 1/4 inch to take off of it. And go back to Y, and then go back the other way. That's a 3/4 inch carbide end mill I'm using. So like I said, I'm gonna turn the air off there. Is this a stupid idea or not? Am I? I want to know, do some of you other guys do this? If you're just trying to do a very quick, simple op, just trying to use it like you would a manual mill, instead of setting up on the manual mill, hand cranking the table back and forth. At least this way I know that I can climb cut and it's not going to hurt the mill. So anyway, just something I thought I'd share. I may end up decking it over here using our face mill though, but we're going to end up making this a fixture that I can bolt to some cast iron plates to use for further machining later. So I successfully got the plate milled nice and square within a thousandths of being square to size there. So it's actually the next morning. We're going to go ahead and use our Milltronics to finish out the machining on this fixture right here. I had a little bit of help from my friend Steve up at Milltronics. We got on the phone, helped me do some programming, some things I was lost on. I've got to stick with this and continue to use it so that I can remember how to do the programming on here. Once you understand the software, and I think it comes down to a lot of like muscle memory, knowing which F keys to go into and continue navigating the software to do the things that you want it to do. Sometimes it's finding what you're looking for somebody like me that doesn't have much experience with this. Guys that's been doing this a lot, this is second nature to them, right? But learning which F keys to go into and remembering what that is, and also the sequence of events that you've got to be able to go in and program. And once you understand all that stuff and you start remembering it, becomes muscle memory, you can come up here and very quickly program this to do a very simple machining op, such as this plate right here. But I want to show you what we're doing. This is going to be a fixture plate for a fixture plate, if that makes any sense to you. And let me show you what I'm talking about. Let's walk down here. Another beautiful day in Florida. Wonderful, cool weather. I love it. All right, so some of you guys may remember this guy right here. This is my Fireball Tools fixture plate. It's cast iron. I machined this to be used for a machining fixture plate, you know, for machining. So what I did back whenever we made this has been a few years ago that we did this. I made this steel mounting plate right here, bolted it to it. And so what this allows you to do is clamp this in a vise, or you can chuck it with a, say a 3-jaw chuck on the inside and spin it in the lathe if you want to. So you can clamp something to that, you know. I have these tapped holes in here so that you can use little hold down clamps, whatever you need to do. The other holes, so I got 1/4-20 holes tapped in there, and I actually drilled and reamed 1/4 inch holes for dowel pins. So if you want to make a fence or something with some dowels, you can do that. All right, I still have a stack of these that I want to machine. I had got 10 of these from Jason at Fireball, and they're still patiently waiting to be machined. This isn't what I'm focused on right now though. What I want to do is machine one of these. See, here's a raw casting. All right, I want to machine one of these guys so that I can use it for some scraping practice. All right, I'm a little out of practice with the scraping. I want to get a little bit of scraping in. I've got all my scraper tools right there, and I want to use one of these just for a practice, a flat cast iron piece to do some scraping on. So this is what I'm making the fixture for, the plate I mean, for this guy right here. So once we get that plate machined, which is going to be what this guy is, this piece, I'll have one that I can mount to these and be able to use it for machining all these other fixture plates. So we'll start with the one. So once we get the steel plate machined over there, I'll be able to bolt it down to this. So next phase obviously is going to be, we need to mill this off right here flat, drill and tap our 4 half-13 holes, and then we can bolt that plate down to this, and then be able to go to the mill. We'll have a plate there that we can catch and be able to set it in there like so, and do whatever machining we need to the top of that. So some more practice for me, which is definitely what I need. We've got some fun little projects like making little parts like that, machining these fixture plates right here. And thankfully I have somebody like Steve at Miltronics to be able to, he can call me, and whenever I have a hiccup here and I get stuck, he calls me and walks me through the program. Part of the learning process, you know. So let's jump over there and see if we've got this programmed correctly and machine this steel plate. Let's give it a run, see if I got this stuff right. I'll probably have to stop a couple of times and maybe adjust the coolant nozzle and just kind of check it, make sure we're not going to crash into it or anything. Should be taking 20 thousandths off that plate. Looks like I've got the airline right there in the way of the camera, so sorry about that. Get that guy up out of the way. Should be on the drill. I just hit feed hold there because what I want to do is let's get some coolant going. Feed hold again, and see if I can get this. This is going to be the counter bore Feed, hold, start. Yep. All right, there we go. Let me see. I'm gonna hit halt. All right, trying to remember what we do here. Stop. So it looks like we got a little too aggressive with our counter bore there and broke our 1/4 inch end mill. Dang it. All right, so we're learning, right? Everything we do is an opportunity to learn from our mistakes and try to better ourselves. All right, so I have one more of those carbide end mills there. That's a Walter end mill. I had 2 of those, so we went ahead and put it back in the collet. I've already touched it off, put in the diameter there, and we're gonna try this again. So one of the things I noticed as well, and I don't understand what exactly I'm doing wrong, the diameter of the counter bore is not correct. I programmed that so that it should be 0.765. That's clearance for the head of this bolt right there. So I put counter bore radius at 0.382, which is half of what I want it to be at, but it's measuring with calipers about 0.735. So I don't know why. I don't know what I'm doing wrong on why that 1/4 inch end mill is not counter boring that to the proper diameter. So we may have to go back in there and modify our radius there. Oh, and the other thing I did, we had XY feed rate at 65 inches a minute. So too fast, I guess. I dropped it down to 25 inches a minute. And so that's about 1/3 of what we were running. Hopefully that'll help. And I think everything else is gonna be fine. So I'm gonna keep playing around with this editing the program here and see if we can rerun this and make this work. Okay, so I've got it modified. Let's try it again and see if I can make this happen. Hopefully we won't break that. I think the problem, I know the one problem is that we had our feed rate way too high. I even verified, I looked up on the Lakeshore Carbide website and was looking up a 1/4 inch general purpose end mill, which is what we got, 4 flute. And I calculated it to 2 thousandths per tooth, which was somewhere around the 32 inch per minute. So I think I've got it set at 25 inch per minute on the feed rate. So slowed it down a little bit. Let's try it again. I'm also gonna see if I can get it to start at block 7, which is about where it should be, where it picks up this tool to start doing the counter bore. I think we're gonna end up having to modify the diameter of the counter bore if it doesn't cut it to the right diameter, but we'll try that next after we finish this out, hopefully. Slowing it down. I'm just using the jog feature up here on the rapids, I mean. Sure is squealing. I don't like that. That should open up the holes. Just taking a little bit out because I used a 1/2 inch drill bit there. Should be opening the holes up about 15 thousandths in diameter. I hit feed hold because what I want to do is look at it again with these bolts. Oh, look, it got it that time. Huh. So I wonder if it was, if we were deflecting that bad, because I didn't adjust the diameter of the counterboard, but now it's fitting. So I don't know, maybe it was deflection. I don't know yet, still trying to figure this out. So, all right, we've got our counterbores done, and it looks like, it feels like the depth is correct. We've got our holes opened up. Oh yeah. So last stop now is to do the chamfer on the outside and inside the counterbore. So hopefully we got that right. Let me go ahead and bead hold, cycle start to finish it. Close that. I've got the air on, but I don't have the air nozzle pointed where it should be. But I think I got my depth right. Heck yeah. That's quite exciting for me to see this done. We could probably shallow up the depth of the chamfer a little bit, but I did that based on the last time we used the chamfering tool, and I had the depth set at 75 thousandths, but I mean, it looks good. We probably increase the RPM to make the finish for the counterbore, I'm sorry, the chamfer look a little bit better. But all right, so there we go. I think we got a successful mounting plate here. I think that's going to work out. I still need to flip it over and machine the bottom, but here we go. There's our bolts. It's working pretty good. Nice. All right. Very cool. Okay, last thing I need to do is go ahead and I want to deck the bottom, flip this over, machine the bottom, and probably do a chamfer on that as well. So what I've got set up, this is a new Edge Technologies Pro Stop, and we've already got it set. And in case you haven't used these before, what's nice about these is that once you get it set, you can go ahead and loosen it up and just drop it or swing it out of the way so that it's not in the way of your cutters. Depending on how your configuration is, you can swing it back or forward. So once you're ready for the stop, bring it back up to where you need and just snug it up, and that should be good. So let me grab a vise handle, wherever that went. Let's loosen this guy up, and we're going to take that out. Now let me go ahead and clear the chips. Set it back in there. And you don't have to ram it up to it real hard. You just want it to touch. Touch it, and it should put it right back in the exact same position right there. Snug the vise, and we are ready to go. And don't forget to loosen it. Drop the stop down out of the way. All right, we made a modification to the program, which is the first couple of blocks for the face mill. And I just set it at a negative 5,000 step. We'll try 5 thousandths and see if that cleans that up there. So, all right, let me see if I can get this running. exit out of the modifications, and we wanted to go to run program, start, cycle start. Let's see if this is going to work for us. I want to pause this. Pause this because I think I forgot to turn the mic on in here. There we go. Resume. Cycle start. I'm going to stop it once we get. All right. I'm just making sure. Yep. Z is at -5, and that looks right. This makes me a little nervous. Let's go with it. All right, so far it's cleaning it up. Gonna be a little shaky in the middle of the plate there. I also modified the cut width there as well. Looks like that last cut was a little bit more uniform instead of just having a little narrow section on the side of the plate. All right, I'm going to hit halt. That looks like it cleaned it up nicely. A little bit of chatter right there in the middle just because we're working on a thin plate there, but I think that's going to work good. Let's go ahead and run the chamfer block and see if we can chamfer the outside. I'll just do the holes with my little Nova tool. Okay, that's going to be block number 14. Enter. All right, that should swap it out for the chamfer tool. Oh yeah, there we go. 8,000 RPM. That looks good. I'm going to stop it once it's finished this because we don't need to run it to where the holes are. Stop. Let's see. Spindle stop. All right, so I run into another problem. Once I stopped it, I hit feed hold so it wouldn't come in here and start cutting this, and I couldn't figure out how to actually just end the program and move the spindle up. I couldn't find the. I just couldn't figure it out, so I couldn't exit out. It wouldn't allow me to move it, so I just hit the e-stop, and I had to so I'm having to rehome it. That was the only way I could get it moved out of the way. So always trying to figure this program out and remember the proper things to do. So anyway, we got that taken care of now, and I think that, let's see, we can hit jog. Let's see here. Something's, I don't know what's happening. Hand wheel. See, I don't know what's wrong. Something's wrong. It's not letting me move anything. And I don't know what I'm doing wrong here. If I go to jog, all right, I figured it out. I had this guy all the way down to 0. That's why it wouldn't move. So that's what my problem was the whole time. Yeah, there we go. Okay, so I had the feed hold switch all the way down to the 0% there, so that's why it wasn't moving. So pretty easy fix. And there we go. I'm just gonna take we got this guy right here, this Noga tool, and we come in here very quickly and just one pass through there, and it chamfers it nicely. Perfect. That guy is done. Got a couple of bolts to modify so I can properly mount the jaws and the vise.